Thank you all for the joining this session. In this session, we'll be explaining about what is fine tuning, why it is necessary, what are the methods over there. Fine tuning is established. There are a lot of methods, out of which we'll be only touching one method because uh, one of the reason is that taking or understanding one method itself it takes a lot of time and effort. And once you are able to get a hold on one method, then you guys can go to the next method. Typically in industry, nobody likes to do a fine tuning. The reason behind is that nowadays models are well matured enough to handle most of the cases. And in the upcoming sessions, you guys also see that LangChain or a Llama Index, all these kind of a um, frameworks, they allow the existing models to build some applications. All these fine tuning approaches are basically done in more of a research where they are trying to find better ways or simpler ways or less compute intensive ways to do this fine tuning. One way of or one area where it is right now intensively people working on. The second is like the big companies like Microsoft, Google, all these companies have a large resources, large data, and they use all this to come up with a model which can really help them. Continuing ahead in this industry, especially in LLMs, there could be smaller models. You guys might have heard about the 2-bit models like P2, Gamma, all these. These smaller models will dominate, also known as SLMs, because one of the advantage with these kind of smaller models is that they can be used in mobile devices, and that's all. That is the all these big companies are behind of that one because once it is in most of their devices like laptops, mobile devices, then they can sell it at a premium price with giving a AI tag to their products, and that's the place where they really make money. And technology will also goes on revolutionizing with this AI advancement. Right now, even doing a fine tuning on a collab notebook is harder because in whatever the free version of collab they give, it's not enough to do a fine tuning. Because I was trying that one of my old notebook was not doing very well. But I can show you what is the process we follow, um, and then we can you can apply that technique for any of the fine tuning approaches. Second thing is that why you should know the fine tuning. The reason behind it, sometimes there are cases which are not handled by the these big models use cases, or some companies have a regulations where they want to keep their data secret, their model secret, all these things. Then what they do is that they create their own model, deploy into their own resources so that it is used as their own proprietary model for serving their purpose. Having said all this, let us dive into the fine tuning and you'll get to know more about it. So, to give a brief overview of these LLMs, to tell or even to understand what are LLMs, the name itself says that large language models. The large comes from, or the large word is attached to these language models because they have been trained on a vast amounts of data, and it is trillions amounts of data, and this data has been collected from the various resources. Examples are GPT-3, GPT-4, Gemini, whatever the state of the model you guys are now seeing in this word, all these things include this one. So the characteristics, like they have massive parameter counts, they are able to achieve a state of the art um, model metric or model assessment. That is, they were able to understand and generate human like text. Even nowadays, humans are taking the help of Gen AI because they are not able to do as efficient as these models. Just imagine how efficient they are. And it is versatility, means NLP becomes one of the basic, or language is one of the basic need of all of the human activities, and this will be going to play a big role in upcoming days. How LLMs are pre-trained? When I say pre-training, creating a new LLM itself, like these GPT-4, Gemini, Cohere, and there are several other models. These models are built from the ground up, like they have created a vast amount of data by collecting a data from the web sources, books, articles, whatever the kind of a resources they can get hands on, they will get all those data from various resources. Then they put a lot of effort in cleaning, because one of the major task of any model building is data cleaning or preparing the right kind of a data. If you feed in wrong kind of a data and expect a best model, that's not going to happen. You have to feed in a data which is a right kind, then you'll end up with a right model. And normally pre-training is done in a two approaches. Masked language modeling, BERT is based upon that one. What it means is that you have a word or a sentence. In within that sentence, one of the word is masked or removed out of it, and given the model to predict that model. Given the model, predict that word. Like it is done like that. Sequentially, it is fed in, and then we will ask the model to find that word. The another approach is casual language modeling. This is approach where you feed in a set of words and ask the model to predict the next word. Like this, it has been trained. So there are basically two approaches, and even in industry, this has been followed. Training is again in iterative updates, as you guys know, if you guys have done regular machine learning training, and uses distributed computing, GPUs, TPUs, all these kinds of resources which are out of the common man's hand or common general public hand, because they need a lot of money to or financing to come up with such a kind of a resources. And these models eventually learn self-learning in the sense they will start to produce their own data, their own modeling, all these gamma, phi, all these being learned on the model or data generated by a big models. What they have done is that, like you just take a GPT-4, they took a GPT-4, asked it to generate few synthetic data. Based upon that data, they have trained one more small model, which is more efficient in terms of generating or doing a specific task. So all this can be achieved. So what is fine tuning? Fine tuning is you take a generic model and you tune it as per your need. Like pre-training is you are building a model from the bottom up or from the scrap. So once you have model, now that model is more generic. Normally models are trained to have a generic knowledge, not the specific knowledge. For example, if I want that model to work on a area like medical or legal, then we don't have a data corresponding to that one. That kind of a customization can be done. Sometimes the generic models are not very well performing for a specific task. Then Fine tuning helps to adapt or even to improve the performance of these models to specific needs or specific area. And it also helps to domain adaptation, like what I have mentioned, specifically like medical, legal, all these known as a domain adaptation. And it helps to adapt to that model domain. And fine tuning doesn't need a large amount of data, but still it needs a sufficient amount of data to fine tune it, because one of the major challenge or major thing we are going to do is we are doing a tuning of the whole model. But if you want to tune it, you need to provide a data which has a specific structure or specific characteristics. Then only model will pick up that underlying characteristic or structure to adapt itself. Otherwise, it doesn't do that one. So it is to be very carefully understood here. Fine tuning needs a data, and the data has to be of very high quality. It should be of high diversity, high variation, or veracity, people calling statistics. So this is a basic diagram you guys can see. I have a raw data, and with that raw data, I have built a pre-trained LLM. Now, I have a specific amount of data which is smaller than the raw data, and I use it to fine tune it. Or you guys can say that I just make the model adapt to a specific domain. I will end up with a fine tuned model. What is the major difference between pre training and fine tuning? So, this could be a question in your mind, that the pre training utilizes large amount of data that I already covered, and it needs a diverse data. It will be of hundreds of gigabytes and terabytes of data. And you will develop, or the main agenda behind the pre-training is to give a strength, or a give these models to understand the language itself, rather than adapting. Like if you want to teach a small children how to speak, which is at that level, they doesn't know anything, and you want them to learn. This is what it is done, and it is heavily resource intensive, means you need a lot of GPUs. And then typically pre-training is done once. Normally, once you have a data, you do a pre-training. Then all these institutions like Google, OpenAI, Anthropic, these institutions do this one because they have a heavy amount of resources, funding, and all that. While fine tuning is much smaller data set needed, as I mentioned, and purpose is for the domain adaptation, and resources is also very less used in comparison to the pre-training, and it is very well suited for the end users or developers or smaller companies where they want to adapt their model to their specific needs. Major differences or key differences between these two is that scaling. Pre-training is about the breadth, like how breadth or how broad we can go around the knowledge of teaching these models about the language. Fine tuning is like a depth, how well or how narrow you can make these models to satisfy specific needs. Sometimes it happens that when you fine tune a model, it forgets its generic knowledge. For example, to take a model which has been trained and it was able to answer the uh, questions from sports and questions from like astrophysics. Now, somebody does a fine tuning on it. What they do is they take all the data available in the internet, which is for small amount, and then they fine tune it for only sports. What happens is that it gets better for the sports domain, but it becomes very worse for the astrophysics. Like it loses or it forgets what it has been taught about that field, but it adopts a new field for a best results. Even though this, I have given a very drastic examples, but sometimes it happens is that if you take a sports as a field itself, if you teach it more knowledge about the cricket and they ask about the football, sometimes it gives a very bad results about the football because it forgets it. So there are pros and cons of it. It has to be taken very seriously because fine tuning looks more some kind of a work we are doing, but it has also downside. We have to be very aware of all those things. That's where the data becomes really important, which tells how or which level you have to fine tune it and stop. That's why art comes from the only from the experience, not from the just doing some fine tuning notebooks and all. It doesn't come like that. You have to go through like what kind of a data you need, how much we need, how much diversity you need. All those things has to be taken care. When and why to fine tune? I think I covered this one. Like you have to adapt it for a new language or a new domain, uh, new information. Sometimes to improve the accuracy, like I have gave the example, like if you want to fine tune it for a specific subdomain in a sports, like for a cricket, to improve the accuracy of its response for that domain, but it start to become very bad for the others. That's the downside. But the agenda is for cricket, then it is achieved. Sometimes it has some kind of bias. Normally, generic models come up with some kind of a bias. They were not good with the medical field or they are not good with the legal field, which they doesn't understand. These models doesn't really understand the meaning. They only understand the structure. So that's what we have bought here. We have bought the structure. Now we want to have a meaning to it. So that's where the fine tuning really helps. But again, it has a downside. Again, this fine tuning increases the efficiency of these models. So what are the fine tuning techniques we have? There are typically four kind of a fine tuning. One is full fine tuning. Full fine tuning in the sense you have a model. When you fine tune it, you are going to change all the parameters or all the learnable parameters of that model. That is full fine tuning. Nobody does it. Nobody does it, but that's known as a full fine tuning. Typically, this kind of a things is done in CNN or convolutional neural networks where you build your own model, where you train all the parameters or you feed all the parameters to satisfy your needs. Even LLMs can be done, but LLMs are not within the reach of a general public where you can see the full fine tuning. But CNNs or convolutional neural networks has been there, and people can even work on the Google Colab to run them to just to classify cats and dogs, all those kinds of things. Then there comes a parameter efficient fine tuning and instructional fine tuning. Fourth one is reinforcement learning with human feedback. Means when sorry for that. Once the human response is model response is generated, the human will evaluate whether the generated response is good or bad. If it is bad, then he will say or he feedbacks or gives the feedback to the model, say, whatever you have done, it's a bad. Can you improve over it or can you regenerate? Then it readapts to that feedback. That is what reinforcement learning with human feedback. Okay. So just to elaborate on each of these topics, full fine tuning initializes all the weights, trains specific data set, gets all the model parameters. Advantages can achieve best performance for a specific task, allow full model adapt. Challenges like it is computationally expensive, requires large amounts of GPU, risk of catastrophic forgetting. When I say catastrophic forgetting, the example which I gave, once a model is trained for a specific domain, it starts to forget the other domains like physics, chemistry, or any other sports, movies. Once you adapt it to that one, it forgets the knowledge about the other domain. Then, if you ask any questions regarding that one, it will be very bad answer, or even the answer will not be right also. So fine tuning BERT. Okay, BERT is a very small model. Everybody can try it. Even I used to work with that one in the early days, and they are very efficient. And I like them. Even sometimes I use them for a small purpose. And even industry also uses them. Most of the industry. So to give you a picture level, uh, this one. So pre-trained transformer model, fine tuning. Like in the fine tuning, you keep the some of the weights frozen and you update the only small part of it. In full fine tuning, you update all the parameters. Just to give it in terms of a image, this I'm showing. The second one comes parameter efficient fine tuning. This is also a part of fine tuning, but there are several approaches. As I have mentioned, research is going on in this direction where they want to come up with newer approaches of fine tuning. And LoRa and QLoRa are one of the popular ways of doing fine tuning nowadays. Or people liked them. Why? Because you don't fine tune all the parameters of the model, one thing, and the number of trainable parameters also got reduced, or they made sure that those are also very small in number. Due to this, people liked it very much. And quantization, QLoRa is one more level where you quantize your parameter floating point. Like one, when I say quantize means you have a number which can be 32-bit longer. Now, if I shrink it, I can make it into a 16-bit longer, or I can use a 16-bit precision to represent it in other way. Then I can even shrink it to represent it in a 8-bit, in next in 4-bit. Typically, full model or a full parameter will be in 32-bit. Some people use 64, but 32-bit is most commonly used. 16-bit is half a bit, it becomes half of the 32. But normally, when we go for a QLoRa approach, we prefer to have it in 4-bit and 8-bit. And model doesn't really perform well at this bit because its parameters are not efficiently fine-tuned. And there are no really models over there, they perform very well at this level. But this is very good for a very small purpose or very small chips. How it is done? Like we can see on the left hand side is the regular approach where you have input data, you have a pre-trained weight which you are not going to touch it, and you have the other side the weights which are updated, and you get the fine tuning. This is regular way of fine tuning. Normally fine tuning is done only for a few layers which I have not shown here, but I hope that you guys understood. When I say fine tuning, I'm not going to do for a whole model, but specific layers only. The second kind of approach is LoRa, low rank adaptation. What is that low rank coming over here? Means normally weight is a metric. If you guys have done a hands-on work with these all kind of LLMs and or mathematical way, it's a matrix. When there is a matrix, you represent it in a space, it becomes a very high dimensional space. What these guys did is that, why can't I take that matrix, shrink it down, that matrix, and represent it in another dimension? This is typically a similar case of principal component analysis. If you go to traditional machine learning, where if you have a 100 or 200 features, what the principal component analysis does is that it can bring it those features down to like 50, 20, 10, whichever number I want. so that all those information is consolidated at lower dimension. This is what they did. What they did is that they shrinked the whole matrix. As a result, the number of trainable parameters shrinked, and then they re-shrinked it back or re-upscaled it back. From the shrink, they did the training, then they upscaled it back and combined the output together to end up with the final result. Why the scaling is required? Because pre-trained model matrix is having a dimension, and I have to match with that dimension. So upscaling is has to be done, and this is done in mathematical or in a matrix way of transformation, and it is typically well standard and well known in the these things. So to give you a very high overview how it is done, this is very mathematical intensive. If you guys want to study it, you guys have a several research papers, and even in YouTube, so many people have explained it. But yeah, I also made a attempt over here. So parameter efficient fine tuning has other methods like precision tuning, adapter layers, prompt tuning, and there are several other methods. This is not the list. This is very small list what I'm showing you guys. And this ORAP and DDP are distributed or reinforcement learning based approaches, uh, but these are also part of fine tuning. And these methods become more popular nowadays after the GPT-3 and GPT-4. GPT-3 and GPT-4 all have been trained on the reinforcement learning approach. Means there is a reinforcement learning feedback which takes or which gives a feedback automatically to the model. You are going in a right direction or a wrong direction. That's why they are able to achieve very state of the art um, results. Then the instruction fine tuning. In instruction fine tuning, you have the prompts, task specific prompts. Based upon the prompts, you vary. It's not a very what you can say. Means if you say, see, normally when the release happens, all these release happens, they have a base model. The base model is just a model which is not intended for a chat kind of a approach or a chat kind of a purpose. What these guys do is that they make an instruction tuning. It's like you have a question and you have an answer. That kind of a behavior they add it or give it to the model so that it will start to respond in that way. Otherwise, it's a model just for the generation of text, irrespective of what you ask. It just generates it. So it's like you have a prompt and you have to complete that layer or that addition they added during instruction fine tuning. That is also since this is the whole process of fine tuning. Like you make first the take a one pre-trained model and adapt it to certain um, domain, and then you put the instruction on top of it to be behave for the chart. So it's instruction fine tuning. So to give you more detail, so normally it improves the model better, especially in chat kind of a approaches, and also it gives very well these things like other domain specific knowledge, and people prefer this one more over the other models. Like you have a prompt, you can give a prompt to the model saying this one, and then it does this task on that one. Otherwise, asking a question to these models is a really hard job if you don't have a instruction fine tuned models, and most of all we use are all instruction fine tuned. So this is to give a high overview of what is reinforcement learning. Reinforcement learning is a kind of a approach where human feedback is needed, and reinforcement learning, if you guys are aware or well known about it, that it's a kind of a approach where a agent is um, taught or they teach a agent how to optimize the best paths for a given problem. That's the underlying approach or underlying uh, thinking or they will want to make it like that. Like if you give a cat and put it in a maze and tell it to go to the milk, then it has to find the best route to reach over there. That's what they do it with this model also. They have a neural networks and they ask it which path is more efficient and which path is right. So find that path such a way that you are optimized for that purpose. So it's a reinforcement layer based learning. Here it is mostly unsupervised, but one of the layer is supervised. It's a combination of supervised and unsupervised. But once a model achieves this one, this is known as a AGI, um, artificial general intelligence. So nowadays, our GPT-5 supposed to be trained on this approach, reinforcement learning, not with a human feedback. It's already done. Like present GPT-4 is learned with reinforcement learning with human feedback. Means they have fine-tuned the complete model with the human feedback. Means once the response is generated, they took it back and said that this is good or bad or rated it so that model gets the right direction or right way to optimize the results. Yeah, thank you. This is all from my side. If you guys have any questions, I'm happy to take it. Thank you.
Yes, Basant. Yes. If you want to show some code related to the fine tuning, you can share some for code.
Yeah, I will show that
Just
one once
yeah.
if they have any doubts over here or any issues over here.
Yes,
So
you can
we
ask
can
your
go over
questions,
that.
as person. Yeah, as person said, you can just go turn on your mic and ask questions.
Okay. I assume that nobody has any questions because everybody has understood. That's why they don't have any questions. That's the understanding. I'll go ahead. Um, I
Yeah, we can
really,
Vijay or Joshna, right? You can have if you have any questions, you can ask.
No questions at the moment. Like whatever Mr. Basant has told, it's all very clear. Thank you.
Okay, okay. And
yeah.
Vijaya, what about you?
Nothing for right now. I have to go through it one more time, then I will get some
Yes,
information.
yes. Okay, sure. Yes, Basant, go ahead.
What, yeah, whatever I have shown here is very fundamental. Most of people might have know about it. I am well aware of it. But when we speak about LLM fine tunings, I needed to tell about the context. That's the idea behind it. And if you guys are well aware about it, that's a very good. Um, yeah, let's go to the code. I'll just go to the code side. Normally, when we try to fine tune it on a collab, we will be having issue with the memory. I am also having the same issue. The resources, the multi is full. This is good now. So this is to check the GPU is active or not. Yeah, it shows it's active and all the details. I'm going to fine tune a Llama 2 model. Why Llama 2? It's very basic model and any model you can choose. It doesn't have to be Llama 2. And I will leave that exercise to you guys where you guys can try any generic models. If it is a 7 bits, good. If it is a smaller than 7 bits, really good to fine tune on a collab. I can show you that this breaks right now in the middle because 7B itself will take a lot of memory. Um, Normally, I should have been tried with the smaller, like 4-bit, 6-bit kind of thing. Then again, there is no point in quantizing that model because it's already quantized. So I did not see any kind of a this one. Install the all the necessary libraries like bits and bytes is for the quantization. We can go to 4-bit, 16-bit, 8-bit, whatever kind. Feft is a library for making this parameter efficient fine tuning approaches. There is a GitHub repair related to that one. Accelerator is again one more library which allow you to fine tune. Transformer is very well known if you guys are heard about the Hugging Face. Dataset is again a um, from the Hugging Face for the data set or maintaining all these data sets. It will take some time to what is that? Install all these things.
Yes, just now you can go ahead. Ask the question.
Uh, yeah, sir, your voice is little low. Like,
Hello, can you hear me now?
yes, it's better. Yeah.
Yeah, yeah. I'm just waiting for it complete. Get it complete. May have to rerun because it has some dependency issues. Let's rerun. So one of the problem with Colab is that if you use newer versions of models, it will start to show you the dependency issues and figuring out what kind of a version is um, it understands is again a time consuming one. That's again a process, especially when you are working in a collab. This is you frequently face it. Yeah, it doesn't have any issues, but it has a dependency conflicts. Login. I don't know why it's not taking something. So here I am just picking any data set which I just came across. You can pick any data set. Make sure that that data has some kind of a format. Let us see what kind of format it has. Most of the time you will spend on analyzing what is the format of input data, what is the quality of input data. Let's load it. Let us load one. Okay, you see that it's an instruction. This is known as the instruction fine tuning because it's already fine tuned on for that one. Like you have instruction for a model. This is the output. This is prompt or a question you can say. Prompt is technically a question. Instruction is we gave instruction to model to behave in a certain persona or on a personality or a characteristic, and output is to generate. To give you guys an example, let us say that a model is generic, but I want to generate some of the responses for a legal purpose. Then what I will tell, or I will ask the model to behave like, I will tell it, you are an legal expert with so many years of experience. Now your task is to answer the questions which are relevant to the legal. Even I can make it very specific, like legal generic or legal civil based questions, something like that. So what it does is when it fetches the data in the backend, when it collects the relevant documents or relevant information, it filters it based upon this criteria that okay, I have to be a legal advisor, I have to focus on the civic or a civil based problems. So it filters it out and brings only those knowledge, and it adds with the query and generates a response. What is generating a response? It takes all of those things, goes to a generator and tells that this is my generating or this is my space. Generation is again a vector space where you point it out and all those things. It's too technical, but if somebody is interested, can dive deep into that one also. So it takes everything, goes to a generator and says that okay, generate me answer based on this one. Generator, what it does, it takes them and generates the answer based on that one. So that's all happening over here. So let us have the data set. Yeah, this is the data set. Just I have created a map, nothing else. Now it became a Hugging Face kind of a data set, having section, input, output, prompt, and text. Loading the model. I'm loading the model. This place, you can place any model. Let me check. Do I have another model? Okay, with another model. Where did I check? Uh, Let me check. I can redo everything. Okay. So this is just a loading a model from the Hugging Face. If you guys have worked with the Hugging Face, you guys might have aware of it. Any model, if you start with a bird, it's a very good normally. You will understand all these concepts very well. But by this time, you guys, I believe that you guys might have aware about all this, like a tokenizer, uh, auto model for casual LLM. Now, right now, I'm fine tuning the casual LLM. Other type of model is like a bird, which is um, masked LLM. It's not right now. I'm not doing for masked LLM. It's a casual LLM. When I say casual LLM, it predicts the next sentence based upon the previous sentence, like that. So what are the bits and bytes? Bits and bytes is a library which will shrink all the model parameters to lower bytes. Like as I mentioned earlier, from 32 bits, it can bring it down to 16 bits. From 16 bits, it can bring it down to 4 bit or whatever the bit you say. From 32, it can all the way can bring it to 16 or 8. It has internal process, but that library does everything. It doesn't have to do it by hand. So that's what that library says. Like load it in a 4 bit type also and bit whatever the float size also it is mentioning over there. So we have loaded. This is model loading from the Hugging Face, but here we are quantization we are mentioning. You can see that quantization config. What it is does is that instead of loading the model in a regular format, now it is loading the model in a smaller bit format. It takes some time. Still, it has to do the whole model loading from the basic thing and then converting them all it has. So take some time. Just I am adding one more model here to load this one also. Like load this is same complete. Let us change this one model two. Mm, Again, it will take some time. Here, copy. I don't want to make it. Uh, Parallel loading two marks will not accommodate in my CPU. This one it will not upload. Let us not make it right. I can show it for this. Even some people check the tokens. Like normally, one of the major issue in these fine tuning the models is that you have to when you have a custom data set, you have to make sure that data set length or the input length has to be of same size. And if they don't have a same size, make them same size by adding a pad to the uh, input data or uh, what is the sentence smaller than the uh, standard or whatever we wanted to feed it. So that way, all the data set which enters the model have a same length and it generates the same output or same level output. That has to be taken care, and people do worry about that one, and they do make some changes to. Let us do the tokenization. Tokenize the data like model name, remote, because based upon the model, I can get the tokenizer. Using that tokenizer, I will now pad it. The pad e token means add a token for the end of the thing. I have not added it, but I have just initialized it. This is first config, which has LoRa config, all these things. You guys can check it the documentation because that is again a topic by itself. You need more technical. So if you guys have worked with hiking phase in earlier any of the projects, you guys know that transformer has a training argument. Like when you want to train any model with the transformers or especially with the hiking phase transformers, you have to first initialize the um, transformer arguments and then you can train it. And here I have made some kind of a what you can say, parameters that is just for the training purpose and add those things to here. The same thing I can add directly or make a this one and add any about this time. So this is the trainer, like parameter efficient trainer, which I'm going to use. Otherwise, it will be just a trainer if you are using direct. Here it breaks down. Not here. Okay. Now, what it is doing is it is just initializing trainer with the tokenizer model data set config, the config which we have used in the previous system given and arguments. These are the training arguments. It's just initialization, not training. Now, now the training can start. Very simple, but needs the resources. The moment resources go above our range, it will like say it's gradually increases. We guys can observe it. Let's see. See, it's already topped up to 40. That's what I'm having an issue here, that it's not able to load into memory. By saying it's going out of memory. Once you have trained, you can check the input and output. Let me check the that one. I think it's not going to, because I need more CPUs here. Let us do one thing. Let's not load this guy. Let's manage resources. Delete this chat. Terminate it. Okay, close. Let us not load this guy. Let us load. Data set is loaded. And the data set is good. Study, restart, we have to go here, get the agent page, copy. I believe I too will be able to train this. And where this one could be commented. And we are going to use the color topic and enable this card. This may pick as a model. So, create the whole code again. Yeah, one of the drawback of working in Colab is that you have to redo everything all the time. Fine, 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 fine. here it should not have any problem. So what it is doing is now it's downloading the model and initializing it in my memory. Let's check my memory how much this is. It is not using any GPU, but 2.7 GB RAM. Once the model gets loaded into the memory, then the memory will start to show its real color. So this is the reason why you guys need better resources and more computation because this is a computation intensive work. That's why most of the people stay away from it. And also the one of the problem with this problem already to it so the model was downloaded, it doesn't need any other thing. There is no working or of the settings has to be redone, and trainer. Right. It will take some time to train, and sometimes it will train in the beginning very well, and at the end of training, to add any more dB. At the end, it will be start to spike up its memory, and that's it. They are not able to train anymore. Yeah, it does. You see, spike up. Training on the Colab is very hard. You know, it is very small model. It is a very small model.
Okay, okay. For tomorrow session, we can utilize Basant. For tomorrow session, we can utilize AWS SageMaker instance.
What is the GPU it has?
Yeah, we can create any as much as GPU we required for 1 2 hours.
Okay, okay, yeah, we can work on that one. But basic idea is training with the Hugging Face is the same. Since you guys just saw that I just swapped the uh, what is that model and kept everything else. And if instead of 4-bit, I can go with the 8-bit also. It doesn't matter. Like if tomorrow I want. Again, when I go to 8-bit, it needs more memory now. I can make it a 2-bit. I can create a lesser memory now. So it depends upon what kind of a model and what kind of a parameters I'm working with, and how do I contact that model. I think we should be having a way to. So I'm just checking what are the models they have to be begin parameters. Give me what his name like He has not done any. Okay, this one. Okay, he has done it, but we need to check. Let's check. Okay, I copy this guy and I have to clear my clear my dump. Clear again, redo everything. Let me check this one also. Right.
Basant, what does how much Google Colab Pro gives in terms of GPU? Same, right? But it will be
Okay.
accessible. Same, right?
Yes, Google Colab V has a better this one also, like I can change the runtime time. Like right now, I'm using T4, which is a just a 15 GB GPU. When I go to A100, my GPU will increase. Uh, I think that's the max here in this environment. A100.
Yes, yes, yes.
I think if you have a around 50 GB to 80 GB, you can fine tune most of the models, like these 7B models. Uh, but again, fine tuning is a computational intensive, and sometimes we end up with a very bad model. So it's a very repetitive process, very headache process, because input data has to be very good. Right now, whatever the input data I have, again, I've taken it from the Hugging Face, which are well curated data from the uh, community. But in a real life scenario or real world scenario, you will be not getting such a beautiful data and such a large amount of data. There, you have most of the time you'll spend on cleaning the data, getting the more amount of data, getting the quality of data, all the things you have to work. So that way, it is more different than what actual real time fine tuning is.
Okay, we have a question. Okay.
Yeah, I'm thinking like suppose let's say when I learn this, so we'll put for learning purpose, we can have like a 2-bit bits and bytes configuration, so it will run faster. Is that possible?
Yes, it is true. Again, problem is that when I load anything into the, it's like there are two things we have to consider. One, I'm loading model into the memory. That itself takes some RAM. Second thing, to train, I have to load the training parameters. Even though I'm using parameter efficient approach and quantize them, still I need like a double amount of memory. If you have, I think there is a one podcast or one on a YouTube itself, the Cohere, the one of the Cohere, Cohere or Mistral, yeah, Mistral person who trained it, he well explained that how much memory is needed to fine tune a model, and he gave means people have come up with a smarter approaches now how to manage memories itself when fine tuning. That is applicable very well for a big models and when you have a huge resources because that needs a really very high level large high level code changes and it's not easy to do in a just collab or this one because it has a lot of dependencies and all those things but it can be doable for 2 bit and 4 bit and that's what I'm trying to do here. Let me check model name
Basant,
because yeah,
so when we fine tune, right?
yeah.
So the memory of the LLM is nothing but the trained GPU or the RAM or the memory of the system it utilizes, right? It accesses from that.
It's basically loading everything into the memory. You are not
Yes,
leaving anything. Yeah. So
yeah,
because
15
of that
GB
one,
of
your memory, yes.
15 GB of
So,
GPU utilization is become the memory, right?
yes. Typically, 100 GB of memory is needed for most of these models. That is well known fact. And I have trained the smaller models, but there is no point in training, fine tuning the smaller models because they are already doesn't achieve very well. I have done that one also.
Okay,
Yeah,
so
this
when
is
you
a good exercise to check whether your data, means again, data curation is a hard part, but your data can be done very well curated or not. Yeah. What was the question?
you can answer them like to have more information, like does the normal LLMs have the memory? We directly access it, right, as an API. So the API itself or the memory or the pretend right memory will stays with the provider, right? So it can also get our data.
No, I did not get the this one.
So, so whenever we directly take LLM, right, loads our LLM,
Yes.
yeah, Llama or
Yeah.
any stuff, we're not installing it. So the memory of the pretend LLM is with the provider, right? The API provider.
Yes. For example, for GPT-4, this is true. Uh, but for the Llama models, there is not the case.
Okay, okay. So then, so where they are actually hosted, does they also have any threat to the data which the user is using?
No, no. Normally, you can download everything. Like for
Yeah, we can
example,
download.
from the Hugging
Yes,
Face, yeah, from the Hugging Face, you'll get everything. Okay,
yes,
this
yes.
is
So yeah, you can. If anyone want to directly use those LLMs, they can utilize Hugging Face. That is a best option.
yes,
Yes.
best option because everything is available. Even the what is that? Weights of the model is available. That's what I'm doing. I'm just downloading those weights, loading it into my memory.
Yes. So you are
That's
doing
what
also same
serving
here,
me
right?
the
You are
yeah.
connecting your Collab with the Hugging Face token and utilizing the Llama from Hugging Face.
Yeah. I had one more. This one I am not able to find that one. Where did I get it? I trained a smaller model. Let me check because I have so many Google accounts. I have to look into all the Google accounts.
Yes, if anyone want to download completely Llama model into this system and utilize, they need to have more compute power and GPU, so that then only it can run on local. So mostly every model the company uses, they will be having like hosted models on somewhere. It may be cloud hosted or Hugging Face hosted or Cohere, right? So any provider will be there.
I could not find it. But somewhere I wrote it. Um, where check this one. The fine. No, I have not fine tuned because fine tuning is really hard to be keyboard also. Yeah, yeah. I think I will check it from my end. There is one more way using CPP Python, but again, loading any model, one smaller model like let me share my screen. I can show that. You guys can see my screen, right? Um, the block is one guy who normally posts the various versions of the model. If I go to this one, you can see that uh, here you see he hosts all these models 8-bit, 6-bit, 5-bit, 4-bit, 3-bit, qubit. From my previous experience, till 4-bit loading is not a problem, but fine tuning is very hard. 2-bit you can load, you can fine tune, both you can do. The problem is that the model is not helpful. So the bottom line is that because you cannot further quantize a model beyond 2-bit, it will become a 1-bit, and 1-bit models are normally bad. So fine tuning has to be done beyond 7-bit. This is my general experience, and model becomes very good, or you can say better than what the other performance or base model it does. Beyond that, fine tuning doesn't make any sense, and people are not doing it, or people have done it and they found that that is not doing very good job. That's the bottom line. But fine tuning or whatever the approach I showed, that is quite generic approach and well known approach. People in the industry also use it. And the only difference becomes from model to model is how you load it. A or from the Hugging Face, how do you get it? Like for example, right now I was trying to get GGUF model. GGUF is a one more kind of a extension. This you guys can see. This is a different extension. Let me say that one also. Sharing screen. See, GGGF is a different format, and loading that one itself is a different approach. And there is a well known, again, this is given well known, like you have to have, where is it? This is CPP Lama. So there are codes for that's how it is done. I have loaded it. It was done the loading. Uh, okay, let me share this. This is all set to the- this is the one. So you can load. This is okay. I think I have able to train this one. Let me check. Connect. Oh, oh, what is it? Connect. And run off. See here, I have given specific versions because I know that these versions work very well. Even still, I have some dependencies. And these are accelerate, PEP, bits and bytes and transformer are common or minimum needed library when you want to fine tune these ones. Here, I think I have used float 16. I have made. Even I can make it float 8. A lot of things. Okay, something. Why was that? Was it?
Can I ask a question, please?
Yes, yes.
What is this is Q Laura or Laura? What does it refer to? Like the number of training arguments? Like what is this RA means?
Oh, low rank adaptation. When I say rank, it's relevant to the metrics. Like, as I said, if you want to fine tune any model, even though you minimize the number of parameters, but still they are very big, like millions of parameters. Feeding them to a memory and fine tuning a model will take again resources. Typically, if you don't go with a QLoRa, your resources to train any fine tune model will be like 100 to 200, even more like GPU, not RAM. You need a GPU of that much memory. Uh, when you work with a, like from the paper, if you have read the GLoRa, it says that it brings down the memory requirement to fine tune model is like 200 or 3000, 1,000 times, like really drastically down. That's why you can fine tune them now using the your LoRa, especially LoRa. Q LoRa should do even lesser, but they don't go lesser than 8 GB. Means you need at least that one. Like normal general rule is that if you have a model of 10 GB, you have to go with 4 to or 6 time of that model, because when you back propagate it, 7 billion parameters with their weights and 7 billion update parameters. All those things will add up, like when you have a cache memory. And then there is again one more cache, the previous this one also. So it's just goes on adding a lot of memory. Minimum 80 GB is needed to fine tune any of these models.
Okay,
Very
like it is
stable.
written here, Q Laura will use a rank of 64 with a scaling parameter 16. So this
Yes,
it is
it's
going to select on its own, like this, like what parameters to use. It will
right now I
on.
have not right now I have not specified any kind of a parameters to it, but uh, if you get into the library more detail, there you can really direct. There are several other approaches where you can efficiently manage the memory, but that's too technical, I believe, for the general audience. But somebody who is interested to know about it, there are well documented approaches in the internet. They can go over them. Like um, KV cache management. This is known as KV cache. Like these are transformer based models. They have a KV and what is the other one? Key value. Uh, Three kinds of a parameters comes, and all those three has to be kept in a memory. And there is a key dot v also comes. So it's a aggregation of all these matrices keeping in the memory leads to a really big memory needed. So in order to avoid this one, people have developed several approaches where even to make it faster, sometimes these models or these calculations are not faster. Even they have came up with several approaches. If you search in the internet KV management or efficient KV management approaches, you will get several. These are all research papers. By the end of the day, um, there are some of the techniques which are proprietary, like what the GPT-4 is using, nobody knows. How it is managing its memory, nobody knows. How Google is doing the actual its memory management, nobody knows, because they don't want to expose, because it's a um, race for everybody to come up with the best model, and whatever they want, they will ready to do that one. So yeah, what we know is very novice or very basic things. And if you are doing to fine tune, I really see that you need all those details or all those knowledge, because again, management of memory, management of all those things is really necessary for any model. Why it is not giving me any this one? Is it
Thank
talking
you.
for some reasons? This is nothing. There is nothing in it. To cancel this one. Something I forgot, then it becomes really painful.
So, Balsant, as you said, right, KV catches some concept which is related to LLMs.
Yes,
Yeah, so when we give some input embeddings, right, as a token, so that is
yes.
creating some weighted queries, some weighted keys, weighted values, right?
Can you reframe it? The question I did not get completely.
Okay, okay. So you just talked about the key values KV catcher rule for the
Yes.
LLMs.
Yeah.
Cache.
Yeah.
So I said this is very important. You said right.
Yes. Especially for
So
language
this
models, because they are based on
this
the transformer.
actually, yeah, I just
Yeah.
want to interrupt here. This actually becomes the weight of the or the parameters of the LLM.
Yes. Yes. They are the real. What is that? Real underlying technology which is used transformers.
Yeah, yes, yes. So keys, values, and queries.
Yeah, KVQ. Normally,
KVQ.
Q is not worried much people, but key and value is having a lot of memory, what you can traces or memory requirement. Because of that one, people try to efficiently manage that one. And especially for that one, TensorFlow is widely used because TensorFlow is having that granular level, what you can say, uh, configuration you can do it, and it's manually done. There are no libraries to do that one, because it's all
Yes,
research based, and it's very not so simple to work with.
yes. This is the underlying technology of all LMs comes from self-attention mechanism.
Yes, yes.
So if anyone want to learn what the underlying technology of transformers, LLMs, GenAI, so they can go with the self-attention paper, which being you can just Google search and go with the archive paper.
I'm doing the same thing what I did earlier, but this uh, what is that, this notebook has a very, all the things I have noted it down. So train, this is also config, same 4-bit, everything. GPU model, same casual LLM. I can load any model here. Again, loading the specific model again needs what model I loaded here. Llama 7B chat. Again, this is a very big model. Let us see. because last time I think I fine-tuned it. Retraining TP is equal to 1. Okay, here I have made cache is equal to false. Here I think I have made cache is equal to true. There is a big difference. No, cache is false. One of the, if you guys are very interested, then I suggest you guys to build basic 1 bit or 1 million or 1 billion parameter model from scratch using the transformers, because PyTorch gives whole transformer as a module. You guys can start building it. You will understand the bits and pieces of all this technology very well. That point. Otherwise, running these fine tuning and other things are very fine. But once I give you a very huge resources, that doesn't make any problem at all. Like when you have, this is just a code flow, like you are just connecting the dots. Beyond that, nothing we are doing over here. Let me check again. It will shoot the memory resources. It's already did once and it is going for the twice second time. Already 10. How many steps are I given? 250 epochs. Oh my god. I did not check with that one. Even number of epochs sometimes adds to the memory. Like if you have more number of epochs, then that's also adds. Presently, I'm at let me reduce the number of epochs. Where did I kept that number? Here, not here. Where did I set it up? Okay, here. Number of epochs. I did not check that one. One it is there. Why it is taking? Okay. Oh, it's a sub epoch. It's not the epoch. Only one epoch. Iteration, number of iteration is going.
Yeah, you're taking the batch size, right? 250, like
Yes, batch size
right,
of 250.
for each epoch. Yes.
Each
So
epoch.
where exactly you can make changes?
Here you
It
can
seems
see
like
epoch
by Mhm, okay.
03 of 1.
Yeah, yeah. So it's by default taking 250, right? Batch size.
Yes, yes, batch size. So it may take some times. It normally takes some time, and here you can see that it's at a 10 GB GPU RAM. It is now constant. I don't know when it will again shoot up, but this is the gist behind it, how to fine tune any model, and you guys can play around it with smaller models. GGUL. I have one more notebook where I can't load one more notebook here because my this one is
Yeah, your resources have been exhausted, right?
exhausted.
Yes, yes.
This one. Okay, I think it's in my different account. Let me share it with you guys so that by the time this one ends, we will be having something to. Oh, this is untitled. Let me GGUL. Where is the share screen? Again, I have to do this same thing. Here I'm loading one more different library, that is Auto GPTQ. That is a what I showed GGUL. it's a similar kind of a library which quantizes in a different format or different technology. You can.
No, I'm not mad, but you should stop now. And sometimes you have to go to the airport.
Joshna, you can mute yourself.
Yeah, I was speaking mute. Okay, so now you guys can see that I'm loading a different model, which is a wizard coder. I don't remember what is the this one. Let me check. It's a 15 billion parameters model, but what is the bit? It's a 4-bit model. It's a 4-bit model. What I'm loading? Am I right? I think I'm loading a 4-bit model. But it's a different format. Like GPT-Q is a quantized GPT kind of a format. Like that's why Q in the end stands for. What is that? Model memories. Tokenizer is 2M. This is 2M. How much it is taking? Okay. It is 9 GB model. I think it's a big model. 9 GB is normally a big model. Let me check. Okay, 9 GB is a very big. No, it's basic model itself is a 13 GB. That's the issue. It's less than 4 GB. 1 GB probably it is. Yeah, it's a very small model, like 1 GB model. Block GGB of you. Good luck. PTQ. You guys heard about the Gwen model? Anybody? Gwen, I don't know how do you guys spell it. It's a model from China. So Chinese have built, it's a very good model, by the way. Even though it is Chinese, it's a very good model. Like it is very well performing. I don't know the real infrastructure needed, but it's from the Alibaba. They have fine-tuned a model, and it is very good for both the Chinese and English. This, whatever the memory here says, that much memory is needed to load this model itself. I'm not happy with that one.
Basant, for how long we can continue the session?
I think we can close it now because we are not doing any what you can say optimal things. I'm just trying to show you guys the various approaches, but I think let the audience take a break and let us digest them all these things, and we can have the questions tomorrow. I think by that tomorrow also I may have taken the smaller model and can show you, but right now I can show you the another model which was going training on. Let me show that one.
Sure, sure. We can take 5 to 10 minutes another, and tomorrow is more about you can go with one demo and the GenAI frameworks.
Thank you.
Okay, this we started training, right? It started doing the work, and it has already finished 50% of the one epoch. Like you guys can see 0.42 of one. So it will train, and we seeing here there is no spike in our memory. That means that it will be training, and you see that there is a fluctuation in the loss because this model is not at all being what I can say, not getting trained very well, because probably there can be two reasons. One, model is saturated, it cannot go beyond that one, and the second reason can be the data which we are using is not optimal for this model. There are several reasons. Yeah, these mismatch also can lead to this one. Again, one epoch is, if you have done any kind of a model training, one epoch is nothing. It's just a visualization. You need at least 100 epochs to fine tune. People do it in 500, 600, depends upon the model, hyperfine parameters, and all those stuff. But underlying message is that fine tuning is not so easy, and fine tuning needs a lot of resources, and fine tuning needs a lot of knowledge about the technology which is going on over here, because you have to update yourself and try everything. Nothing works for the first time, then you have to recome and do this one, and normally we will not end up with a very good model. So all those stuffs. That's why there are several 7V models out there. People are not going with that one. If you see internet, it is filled with rag, lang chain rag and everything, because that's where the real business is getting developed. Agents, rag, because fine tuning takes years. Like generating a data and fine tuning itself is a very hard job. That's why people don't want to or invest their time and money on that direction. There are some people trying it, like
When you adapt it to different languages like the regional language, Telugu, Tamil, Marathi, Gujarati, or whatever the language, then you don't have a model readily available, then you can adapt it or fine tune it. Again, you need a lot of resources for that one. Data collection, resources, and everything. Yeah, I think we can end the today's session. I hope it was very helpful. Tomorrow I can show you the other approaches, but again, fine tuning will take years together to work on. But I can hand over this notebook to you guys. You can try it at your end.
Okay, yes, thank you, Basant. You can share the code or the collab notebook into the Slack group. Okay. And yes, thank you all to for joining today's session. Hope you all learned fine tuning techniques from Basant, and you can update your notebooks which you practice. Write anything, any questions, any doubt on Slack.